Hey everyone, welcome to the Weekly Space Hangout, the 2016-17 season for Friday, September, it's the 16th, 2016. I am Fraser Cain. I'm the publisher of Universe Today. And joining me this week, we've got a crew of excited Weekly Space Hangout regulars. So we've got Paul Matt Sutter. Paul, are you there?
I am excited.
Yay! We've got Nicole Gallucci. Nicole, are you there?
Hi!
We've got Dave Dickinson.
Hey, live from UK.
Oh, he didn't pop up. Weird. We just get
Uh-oh.
Nicole. We've got Yov Landsman. Hey, Yov.
Hey, live from Israel.
Welcome. And we've got Morgan Renberg. Hey, Morgan.
Hey, everyone.
Yeah, that didn't work. All right. So this week we got a bunch of stories. We're going to be talking about the planet Proxima b. We're going to be talking about dark matter galaxies. We're going to be talking about black holes hidden in their own exhaust, unexpected gas reservoirs around large stars, Juno at Jupiter, the penumbral eclipse. We're going to be talking about the status of the Israeli space program. I wonder who's going to be talking about that. We're going to be talking about whether Pluto is the source of Sharon's red poles and China launching its next space station. Now, yeah, Dave Dickinson is invisible. So this is the new season, and we had big plans to do a bunch of new stuff. And we got some of them done, which is great, and I feel really proud for that. And so the thing that's new... it's reversed, is this thing right here, which is this little chat interface. And so what you're looking at here is Slack. So we have created, thanks to the amazing help from the WSH crew, they have their own Slack community, and they have just one part of Slack that is just for the live show. And so we're going to incorporate that conversation into this episode. This week is just a test. So,
Fraser?
Yep.
Maybe what is Slack for those who are not familiar with it?
Slack is a messaging system created by my good friend Stuart Butterfield. And it is a really cool thing for messaging and communicating, and it's free and it's publicly available. And so anyone who joins the WSH crew community will then be able to chat live during the show. And so all you have to do is just request an invite through, it's the WSH-crew. And so in the YouTube comments, folks from the WSH crew are going to put some information in there, and then by next week, hopefully, we'll get more people chatting through the Slack. So that is this is the new communication system that we're going to try and implement, and it sort of gives us a sort of a nice way to maintain a record of all the questions and comments and stuff that happen, because all that just gets thrown out with the YouTube, which is really sad with the comments. So. But I do see the YouTube comments, so I can say hello to a bunch of people, like Larry Beckham and David Dunn, and Jessica Feltz, and Guido Bibra, and Lizek the Spacer, so a bunch of you there. So that is sort of the new thing that we're going to be incorporating, hopefully this season, and this is the beginning of what is eventually going to become a very smooth operation. We were supposed to have guests from the Universe Sandbox this week, but... they weren't able to make it, I guess. So we'll try and reschedule with them and queue them up for another week. Okay, great. Well, let's get on with the actual show, and we will remember how to use all this technology now. So first, I'm going to talk to Paul Matsutter, which is, I think, not only the biggest story of the last month, but possibly the biggest story of the year, possibly one of the biggest stories of the century, which was I'm not kidding. That planet,
You're all in.
Yeah, I'm all in. That an extrasolar planet has been discovered around Proxima b, and I mean at this point I'm sure everyone is very familiar with it. Of course, it broke while we were during our hiatus.
How inconsiderate of the European Southern Observatory.
Yeah, exactly. So, Paul, why don't you give us the sort of the lowdown and the new things that you wanted to talk about?
Yeah, so like I said, the European Southern Observatory announced the discovery of what they call an Earth-like planet orbiting not just any star, but our nearest neighbor, Proxima Centauri. In my mind, this planet is like the most un-Earth-like, Earth-like planet. We don't know a lot about it. We know it's just a little bit heavier than the Earth, or at least something like 20 or 30% heavier than the Earth, but it could be a lot heavier. And we don't know its diameter or its radius, so we don't know how wide around it is. But we do know that it orbits in its star's habitable zone, which is the zone around a star where it's not too hot, not too cold, where there could be liquid water on the surface. The challenging part with that is Proxima Centauri, our nearest neighbor, is a red dwarf star. It's very, very small and very dim. It's so dim that you can't even see it with your naked eye. You need telescopes even to see your nearest neighbor. And this means the habitable zone isn't kind of far out like where the Earth is around our own sun. It's right up close. I think like 10 times closer than Mercury is to our own sun. You have to get that close in order for it to be warm enough for liquid water. And the challenge with a planet that close to a star is you tend to get tidal locking or resonances where either the same face of the planet always faces that star at the same all the time, or it rotates very, very, very slowly. So this is going to make weather on Proxima b, this newly named planet, a little bit challenging, and especially challenging for life. And also red dwarf stars are incredibly erratic. They have tons of solar storms, star spots, and flares. And if you're right up close to it, you get like the full blast every single time. You don't get to ever miss it. So I wouldn't be so excited about this planet in terms of a potential home for life because it probably really, really sucks there. But it is exciting because of all the places in the universe or in our galaxy to look for planets, we happen to find a Earth compatible or Earth relatable, comparable planet, not just around any star, but around our nearest neighbor, which means this is an excellent place for observing, for more detailed observations, for potentially imaging. There's some far out ideas to even send space probes to the Proxima system. So that's why it's exciting for me. It's just there didn't have to be a planet that close to us, but it turns out there is, which is pretty awesome. Not so excited about the chances for life on that planet.
So, I mean, we sort of fell into this trap, right, as we were reporting it at Universe Today, sort of the habitable versus not habitable. And, you talked about this. It's probably tidally locked. It's a flare star. It's a miserable place to live. It is going to be no picnic. So how do you put this all in context for people, right? I mean, on the one hand, this is the closest possible planet that can ever be discovered.
Absolutely.
Right? And yet, on the other hand, we're sort of dealing with, a really awful place to live. So I think people are getting they're getting their priorities a little bit messed up, right? Which is on the one hand.
Yeah, I think there's this mixing of like colloquial definitions of habitable and Earth-like with technical astronomical definitions of habitable and Earth-like. Habitable zone means the planet can potentially have liquid water on the surface, and that's it. It doesn't mean it's a nice place to be. It doesn't mean it's not totally irradiated. Venus and Mars are both in the habitable zone of the sun, and they're not exactly habitable. And then the same with Earth-like. We develop measures based on a planet's size, its mass, its density, to see how close to Earth it might be. But that's just one number. It doesn't really capture how accurately or how much it mirrors everything we know on Earth with oceans and atmospheres and continents and all that kind of stuff. There's so many variables out there. This is just two variables, or a limited set of variables: how close a planet is to a star and how big it is and how massive it is. And it takes a lot more numbers to really describe if a planet is worth living on.
Yeah, and so I guess my feeling with this is that it is an unprecedented opportunity to study a planet around a red dwarf star that is incredibly close. To have one that's only 4.25 light years away lets us study a planet that's only 4.25 light years away, right? That as opposed to the ones that are hundreds and sometimes thousands of light years away. This is in our neighborhood, and we can study
it's next door, and that's pretty cool. Just that there's planets so close to us that's available for study at our next nearest star when there didn't have to be. The nearest planet could have been like 50 light year away.
And it was a total fluke that it happened to be in the habitable zone of this red dwarf star.
Right.
But it is like such an interesting, amazing opportunity that we're going to really try to put a lot of emphasis on this planet. And people are going to be sending up, I bet you there's going to be a special observatory that's really going to be specialized to try and find out more information about this planet. It's an enormous opportunity. And I feel like people are going to get muddied, right? They're going to be like, oh, it's not very habitable, so it doesn't matter, but it super matters.
It's so cool. It's cool for science, all right? And that's enough.
Yeah, exactly. All right, well, let's move on. So,
actually, I gotta take off. Actually,
you gotta run.
Yeah, something just came up. I gotta run. So, thanks for starting with me because that was really well timed.
Oh, you should have. I didn't even know that you were gonna.
I didn't know either until like 30 seconds ago.
Okay, all right. Cool. Well, let's move on.
Fraser, before moving on, we have our guests. They are in the chat. They are trying to find a way to link. Have you emailed them the Zoom link?
They had the link originally, so they would have had an instruction. They would have had an instruction email. Why don't we queue them up for next week? Sorry, Jennifer, but we could try to bring them in. We're in the middle of the broadcast, right? So you could. Someone can give her the link that you all have.
I don't know what their email is.
Yeah, unfortunately, I just got to keep the show rolling. So let's. I'll try and coordinate on the background. So hang on, Jennifer. So Nicole, let's move on with you, and then you can kill time while we organize this in the background.
This is what I get for opening my big mouth.
Yeah, there you go. Why don't you talk about a black hole that's hiding its own exhaust?
Absolutely. So I put in a couple. So this one was a news story from my favorite place, the National Radio Astronomy Observatory, because I like radio telescopes, everyone. And this is an image of a image from an area around a supermassive black hole. This is from the galaxy NGC 1068. Will I break everything if I try and screen share?
Yes.
Okay, then I won't do that.
Yeah, but you did post a link in the chat. Chad can get access to it, and he will work to make this happen. So
I just opened my Slack invite.
And for you to screen share would take away his valuable assistance. So
fabulous.
Yeah. Might even have to fire him. So, all right.
So this supermassive black hole is powering something called an active galactic nucleus, or AGN, in the galaxy NGC 1068, which is one that I once upon a time used as a calibrator. There is the lovely, that is an artist's conception of what it looks like, but there's also a new image down below from the Atacama Large Millimeter Array, which is a telescope in Chile. This is a radio telescope looking at high radio frequencies, or millimeter, microwave, submillimeter frequencies. And what they found is that there is exhaust, what they call an exhaust from the black hole, which is material that has not made it all the way into the black hole. It hasn't passed the event horizon, that point of no return, but it's so much matter is trying to cram into it that it spews it forth. It spews it out. And so they've highlighted that little green blob they're coming from the black hole. Now, we knew that black holes spewed forth material. They have jets of electrons and other particles go nearly the speed of light. But what they saw this particular blob of stuff coming from the black hole happening is it's populating this ring of material around the supermassive black hole. So I'll step back a little bit in the history of active galactic nuclei, AGN. They're very compact, bright sources. Sometimes you see them in the optical, sometimes you see radio, sometimes you see X-ray. Sometimes they have spectral lines that are skinny and sometimes spectral lines that are fat and wide. So there's a wide array of features that they can show. And the current understanding and model of that is that you have a supermassive black hole in the center. You have this disk of material around the black hole. And then you have this bigger, thicker, dusty torus or donut shape around that. And wasn't quite sure what the formation mechanisms of all of these things were. So that dusty torus was thought to comprise of material that was already outside the black hole and hadn't gotten close to it. What they see in this image from NGC 1068, which I should point out is also known as Messier 77. So there's your Messier object to look at for you. That material is actually feeding some of that dusty torus or donut of material around the AGN. So this was, once again demonstrates the fabulous, I know it looks like blobs to most people, but the fabulous imaging quality of ALMA, and that it can get these super highly detailed images of stuff going around supermassive black holes. Now, we're not at the point where we can really image near the event horizon of a black hole. There are several other telescopes spread across the world that are being used to do that. It's called the Event Horizon Telescope. But this is exploring this really complex region around the AGN. It's thought that...
Is this the sort of thing you'd find around every black hole?
Around these supermassive black holes if they're active. Now, our galaxy isn't active right now, so it doesn't have a lot of this stuff going on, these, regions that give off spectral lines and X-ray and synchrotron and all of that. But it's thought that most big galaxies may pass through this stage at some point in their evolution. And so the Milky Way may have had an active black hole at some point, but ours is kind of puny. It may not have been active for long, is I think the thinking there. So it's not something we see here. It's something we see in active galaxies like NGC 1068. And so it's cool to see that in super fine detail, the way that it's powering that dusty donut around it. And now I've made myself hungry again.
Dusty donuts.
It's probably fortunate for us that ours isn't that active, I would think.
It would be so cool, though.
It would be cool to have one nearby.
As long as the jets aren't pointing at us.
Yeah, that'd be a bad thing.
Yeah.
I mean, I did a video about this, that even if our supermassive black hole became a quasar, we wouldn't even be able to see it from here because of the dust and even the brightness. It wouldn't be much brighter than a star.
Well, you couldn't see it, but the radio telescopes could.
Yeah, they'd be freaking
That
out.
would look fabulous.
Yeah.
And the infrared and all of that.
Yeah, exactly. So our special guest made it. Yay, through the healing power of technology. So we've got Dan and Jenn from Universe Sandbox. Welcome to the Weekly Space Hangout. So
Thanks for having us.
All right. So now you guys are just located just across the border, right? In our Pacific Northwest?
I'm in Seattle. Jenn is in Washington, D.C., and then we have other team members in Germany, Denmark, Philadelphia, St. Louis, Chicago, California.
Awesome.
We're a distributed team.
And for people who have no idea what the Universe Sandbox is, which is highly unlikely, because we talk about it quite a lot here, but still, what is it?
It is physics-based astronomy software that lets you ask fantastical what-if questions like, what would happen if the moon collided with the Earth? What would happen if another star passed through our solar system? What would happen if Neptune was next to Saturn? What would happen to Saturn's rings and the two planets? So it's it's exactly what it says. Universe Sandbox. It is a sandbox of planets and moons and stars that you can let run and see what happens.
Now I've got Universe Sandbox 2, and I've been playing it quite a lot, and I love it. I especially love the newest alpha that has a very good handling of the Roche limits and such. We actually worked on a Roche limit video, and literally the day we posted our video, you released that update, and so we missed it being able to incorporate it. But we're now working on a video where we're going to be tearing the sun into red dwarf stars. So it's going to be making an appearance in an upcoming video very shortly, which is wonderful. This is so cool. We're just going to stare at this for a little while. what has been the sort of the big challenge in simulating this kind of stuff?
I don't know, Jenn, if you want to take that one, or
Sure. I mean, so we're trying to do a full live n-body simulation, and we're also trying to make it run on any random person's computer or laptop. And so we've got to find ways to keep things accurate while still letting people run things at reasonable speeds and time steps.
So you bring the science, right, Jenn?
Yeah, I'm the astrophysicist.
Right. And so that, I guess that's a really interesting question. Like, what is that balance between what an average person's computer can handle and what is the depth of the simulation, the complexity of the simulation that you're having to try and run?
Absolutely. Yeah. I mean, there are certainly major limitations on what we can and can't do. For instance, we couldn't do a full general relativity simulation because that would require simulating space-time itself instead of simulating bodies as point bodies. So it's a Newtonian simulation is what we're doing now.
Wow, poor Einstein. Have you guys actually had a meeting about this where you're like, boy, I really love to be able to bring in relativity?
Well, we've talked about, I'd like to be able to add post-Newtonian terms to, show orbit decomposition for massive bodies and stuff like that, but it still wouldn't be full GR.
Yeah, I mean, Roche Limits was one of the ones that you just brought on board, but I know you've got, I look at your development diary and you guys have a list of improvements that you want to make that's a mile long. I think the universe, and I guess as the discoveries come out, you're going to be catching up to what's been discovered out in the real universe.
Yeah, every time news comes out about new discoveries, Dan instantly tries to make new stems for these things.
Is Proxima Centauri B in there somewhere?
Yes, yeah.
Oh, cool.
in the next update, yeah, which we've been working on for a while. So, yeah, roach fragmentation has been revealed issues with other parts of the simulation, and which then we've rewritten, and then that revealed new problems that we've then had to rewrite, and so we've kind of been in this like perpetual feature creep and situation where we've been rewriting large parts of the code. But it's going to be the most amazing update we've ever released once we release it. So yeah, we fixed tons of bugs. So really excited about this new one, and in addition to the fact that just tidal heating and roach fragmentation and just how interesting that is. We've also, Jenn's been spending a lot of time in getting the volatile simulation to work better. So now if you'd like just make the Earth like 100,000 degrees, it'll just kind of instantly vaporize. So, which was an interesting quiz, like, well, what, I mean, that would never really happen, but like, what would happen if it happened? So, yeah.
So for people who play Universe Sandbox, what are some things that they could do that maybe they didn't realize they could? I mean, we've all dropped the moon into the Earth. We've all crashed a bunch of stuff into Jupiter. We've done a bunch of that kind of thing. But for example, right, overheating the Earth or the sun and it just vaporizes. What are some other stuff that I could do in Universe Sandbox that would push this to the danger zone? Maybe I'm not, I wouldn't think to do it.
Well, I mean, a lot of the crazy ideas I come up with, I end up creating simulations of so that we can test them. I mean, and admittedly, a number of the simulations that we include in the game itself are like kind of testing the extreme boundaries of what we're capable of simulating and don't necessarily work as well as we would like them to, but they're kind of there as reference to like remind us that we need to improve whatever, that part of the simulation. Yeah, I mean, a star in orbit of a black hole gets completely, the roach fragmentation of a star around a black hole turns out is just super fascinating and interesting. So, and
how about feeding a neutron star to a red giant, which is a theorized object in the universe? I forget the name of it, but there's a sort of an astrophysical theory about that you could have a binary system where the neutron star gets consumed by the now you're going to look
interior.
at and now you're going to look that up.
Interior to the star, yeah.
Yeah,
it's got really exotic name.
Yeah, or things like blue stragglers, things like that. Or do we know, according to your simulation, if the Earth is going to be consumed when the sun turns into a red giant?
So At the moment, you can speed up time and watch the sun turn into a red giant, but the problem is it kind of blips by because the red giant stage is relatively short if you want to speed up time a whole lot and go to the red giant stage. But we're also improving our stellar evolution code, so it should be exactly the proper radius and should answer that question.
Zach Cody asks, "Is there a way we could blow up the moon like they did in Seven Eves and try and figure out what was the agent?"
I had.
Go ahead.
Oh, I was gonna say I actually have a task on our task board to work on creating a simulation of that. So I think I've been asked that now 7 or 8 times.
Yeah. Yeah. Oh, there it goes. So Dave Dixon just posted. It's called a thorn Zyko. Yeah, that's the object I was talking about. That's a future episode. We're going to be wondering what would happen in that situation. So what is something that a lot of people have been asking for that you would love to do, but it's going to be really complicated to implement?
Life.
Yeah.
People keep asking for life simulation.
Like terraforming?
Yeah.
Yes, all of that. Yeah.
Or being able to
alien megastructures.
Megastructures. Yeah.
So my dream life simulation scenario, and we are nowhere near close to this, but I would be very happy if we were able to get there, is being able to do a dinosaur extinction event scenario where you can drop like a 10-kilometer wide asteroid on the Earth that causes the atmosphere to go opaque, which then kills off plants. However, those are represented. The plants die off, which then causes the plant-eating animals to die off, which then kills off the animal-eating animals. So if we were able to represent life at that kind of, at least that level of granularity, where you could do something like that, and then the smaller creatures end up surviving, I think that could be really interesting. Or plants put out oxygen, animals put out carbon dioxide, and so you get this interesting on a planetary scale, changes in the atmospheric composition from the contributions of the creatures, and then you could do a simulation of the oxidation. What is it? One of the grand extinction events from however many billion years ago that was. There was so much oxygen in the atmosphere, or something like that. So those are kind of that's kind of that scenario kind of really propels me toward. I think that would be really cool if we could do something like that where it wasn't scripted, where it was a pure simulation that just happened to work out like that, or at least something similar to that. So, but life is there is no generic scientific formula for life.
Because we have one data point.
One data point, right? Panspermia, things like that.
Yeah. So how do we? Yeah. But then the other big complication with life is improving the climate simulation, and there's no really simple way to calculate the greenhouse effect given a random combination of atmospheric materials, and so. Yeah, I don't know. We have not figured out exactly how we're going to solve that problem, but because I would really love to be able to allow the user to, randomly adjust the, now the planet has 20%, has now this planet's atmospheric composition is 20% methane, and then what happens to the greenhouse effect and, under that random scenario. So
yeah. We're really good for Earth-like and Mars-like atmospheres, but arbitrary molecular composition of the atmosphere is challenging.
But it sounds like it haunts you enough that it's going to make its way into a future version.
I have no plan. Yeah, go ahead.
We've got habitable zones, and that made people want to terraform and play with things until they could, make things as likely to have life as Earth. But then we gave in and made an Earth similarity index and a life likelihood index. And now they want to see stuff spontaneously growing on their planets with water that are in the habitable zones.
People are saying there's some problem with my audio. I'm not sure how to fix that. Is there a gain on the side? No, it's all balanced. Okay. I apologize for the audio problem. I don't know if we're going to be able to troubleshoot this one. So I guess I got one last sort of big question for you, which is that the quality of this simulation is just getting better and better. And I know that there's a lot of really big simulation projects out there as well. Are you starting to enter the realm where the simulation is being used for science, for people to actually make some predictions like that? Do you see that happening in the future? Is that happening already?
Well, I mean, my understanding is that we're not, well, especially given that like our source code is not open source and a scientist could go in and like examine what's actually happening, that we're not really doing, like, if you're really wanting to run scientific experiments, you're going to want to write your own code so you know exactly what's happening. But I could certainly imagine that you might use Universe Sandbox to like maybe like kind of rough prototype a scenario, or in the case of like a galaxy collision. I actually had someone that did study galaxies. I don't know if they ever did, but they were like, oh, conceivably you could use your software to like position some galaxies and kind of run it and just kind of make sure you get like an interesting collision, and then you go back and take those same parameters, put it into our real galaxy collision code. And then you let that run for a week, knowing that you're going to get the galaxies aren't going to miss. But I don't know, Jen, do you have any thoughts on that?
Yeah, for specific questions, I think scientists would make their own custom code and, have it open so it could be reproducible or at least accessible to people who request it. But people have already been using it for visualizations in their talks and for example problems. Sure.
Actually, I've got one more question, which is actually the virtual reality. How's that? I haven't even tried it yet. It is
better than I expected it was going to be. It is really compelling. The ability to, the Earth, to have the Earth like literally floating in front of you as this sphere that's about this big, and then the moon is way over there, and then you can use the. So this is on the HTC Vive, and so it's got these. There we go. Kind of these grip buttons that allow you can press them in and actually like scale the entire scene. So you actually like shrink the Earth down, and so the moon flies in, and they've just got this. These little marbles floating in front of you. It's really very cool. But then, and then the ability to like, turn your controller into like a planet gun or a star gun. Just launch moons at the Earth, or even reach out and grab a moon and toss it into the Earth. It's pretty cool. As soon as we get this next update that we've been working on for way too long out, we're going to switch gears and do another VR update, and really hoping to kind of like rethink some of the control scheme and make it. I think the feedback on it has been, it's very cool, but the control scheme is a little clunky, and I think that's very fair. And I would like to fix the problem so that the feedback is it's really cool, and the control scheme is not clunky either. So
I love how it's like a moon gun. Nicole, you had a comment.
I do. Well, I have a quick comment and a question. Quick comment is I was on a panel of people at a Dragon Con recently of evil geniuses kill the planet, and like literally one guy's idea was to like set Titan on fire and send it hurtling towards Earth. So I'm glad to see we can shoot planets in some way. My actual question was, do you have educators using this already in classrooms, or have you had requests from educators or stories about how they would use it or want to use it?
Yes, we just began selling the sequel on Teacher Gaming, which is the people that were behind Minecraft EDU and Kerbal EDU. Minecraft now got sold to Microsoft, but so that company is now selling Universe Sandbox to schools. We had been giving away the original version of Universe Sandbox, the first one, to schools. And then originally that was part of a STEAM for Schools program, which was a educational initiative that Valve and Steam put together that then they since abandoned. We were part of that, which was cool when it was happening. So the short answer to the question is yes, it is being used in schools. The exact extent is unclear to me, but we're committed to improving the software for that use specifically, like as a demonstration tool and allowing you to run experiments and demonstrate these interesting phenomena. I mean, I would argue it's hard to imagine a more interesting way of learning about space than to be able to directly manipulate it and see what happens.
Other than like going there yourself, which we can't do.
Right.
Morgan, you had a comment or a question.
Oh, I think I just wanted to sort of put the difficulty of this into context. And when we simulate the rings of Saturn, basically a state-of-the-art simulation would be to do 1 kilometer by 1 kilometer box of the rings. And you run it on a workstation. It might take a month to simulate a few days worth of movement in the rings. And so to be able to sort of run arbitrary scenarios right at the tip of your fingertips and throw planets into other planets and things is an incredibly challenging thing to do. And it's really impressive that this works at all, much less as well as it seems to.
Well, that I think is your pull quote. That's your Twitter quote right there. It is impressive. This thing works at all. Not to mention the level of, and keep in mind, Morgan is a this is his mostly full-time job, is focusing on the rings of Saturn. So that's high praise. That's awesome. Cool. Well, hey, thanks to both of you from the Universe Sandbox. I really appreciate you coming. Thanks for being our first guinea pig for the new season. But I want to sort of do another invite, which is I'm adding a segment here on the YouTube channel, probably Mondays, where we're going to be playing some games, some space games. People have been asking for this a lot. So I figure maybe you come and hang out again and maybe we can play some Universe Sandbox and give people a more thorough demo of how the game works. So
that sounds like a lot of fun.
Yeah. So
I'm down.
That sounds great. All right. Well, thanks a lot. Now, for people who want to buy a copy of the game, where do they go?
Universesandbox.com. And you can buy it there on our website, or there's a link to Steam. Anyway, both ways you buy it, you end up getting a Steam copy. So, yeah, Universesandbox.com.
Perfect. I think I got mine through Steam. Well, thanks for joining us, and we'll talk to you in the future.
All right. Yeah.
See you guys later.
Thanks so much.
Well, Morgan is telling us he's got to run, so let's quickly switch to Morgan. And what do I want to hear from Morgan? Go, Morgan, go.
All right, let's talk about space stations, because this just happened.
Sure.
The rest of it's old news. But yesterday, China launched its second space station into outer space called Tiangong-2. And this is part of their plan to work up to having a full outpost in space by the early 2020s. Now, we have the International Space Station up there right now, but it's only international insofar as you can come if you're not Chinese. And so obviously China wants to have a part to play in our exploration of space as well. And so they want to put up their own permanent habitat. But it takes a lot of effort to do that. And all the other nations that have worked on building a space station have done it in stages. The United States had the Skylab program. Russia had the Mir program. And together those were combined into the International Space Station. And so China's been following a very similar path. Back in 2011, they launched Tiangong-1, their first space station, and sent a number of crews of astronauts up there to work for small, short periods of time. And then, having learned from that, they redesigned the space station for Tiangong-2, launched that yesterday. It'll soon assume an orbit of 393 kilometers, and that's an altitude that actually is in the same range as where the ISS orbits. So all those people saying that the plot of gravity was completely unrealistic because you couldn't go from one space station to the next, we're probably still right, but at least they're going to be in the same neighborhood here. And then late next month, a crew of astronauts will arrive to spend 30 days in Tiangong-2 and sort of get it checked out, run some initial experiments about living in space. And then sort of in the spring of next year, a supply mission will go up, resupply the space station, and prepare it for another crew. And then they'll continue to learn with this space station for the foreseeable future. And then the next station they plan to launch will be a permanently inhabited one. It'll be about an eighth or a tenth the mass of the ISS. So we're talking about something much smaller than the ISS is today, but it will be large enough to support a full-time crew of astronauts, just like we have aboard the ISS today.
Yeah, so I mean, everyone's so focused on what's going on with the U.S. efforts, but the Chinese are still continuing to make steady progress towards their own space goals. Have they elaborated what comes next?
Not beyond the fact that they intend to launch a larger station in the early 2020s. That's been their goal for a while now. And one of the sort of nice things about not being embroiled in a fierce space race like the US and the Soviet Union were in the 1960s is you can take your time and complete all of the intermediate steps first. And so they really have. They first sent up some uncrewed capsules. Then they put crews up there just orbiting the Earth for a couple of days, practiced bringing those back. Then they launched the space station up. They allowed it to orbit empty for some time. They resupplied it. They sent astronauts to it. They brought it back, where it's coming back down in the next year. They sent up a second one. In the process, they're really just taking one step after another to extend their experience until they're ready to launch the full station in the early 2020s.
Well, we'll have to see what happens. I still think it's a race for the moon at this point. I would not be surprised if the Chinese are the ones who first set foot on the moon before the Americans return. Although we'll see if Elon Musk beats them all to Mars. So, thanks, Morgan. Now I know you got to run. Did you want to talk about your second story now about those red splotches on Sharon quickly?
Sure, we can talk for about those. If you remember last year, the New Horizons spacecraft flew by the Pluto system, took all those gorgeous images of Pluto, but it also took images of Pluto's moons. And the largest of those moons is one called Sharon. It's about 1/10 the size of Pluto. So we're talking about a very substantial object here. And one of the interesting observations of Sharon is that both its north and its south poles are extremely red. Most of the moon is kind of this grayish, sort of standard icy color. The poles are very red, and it's been a puzzle where that red color came from. We think that it's probably methane. But the real question was, well, how did that methane get there? Because all of the methane is on Pluto. Sharon doesn't seem to have any methane other than at these poles. It has no atmosphere of methane like Pluto does. And so this work that came out recently is talking about a simulation that has been done to show how this process might actually work. And it relies on the fact that the poles of Pluto are in shadow for 130 years at a time. That's Earth years. So from 1860 to 1990, the North Pole of Pluto was in shadow. That means it's extremely cold, maybe the coldest place in the solar system. And so as Pluto sort of lost atmosphere, just like the Earth's losing atmosphere, some of that is methane. And if that methane happened to bounce into Sharon and hit this really, really cold region, it could freeze to the surface where it would mix with water ice. And if that was all that happened when it got sunny again in 1991, that methane would have evaporated away. But instead, ultraviolet light was bouncing off of particles in Pluto's atmosphere and hitting the surface of Sharon. And when ultraviolet light hits methane, it fuses it into heavier organic molecules, things that we would call tholins. And these heavier organic molecules are heavy enough that even when Sharon heats up a little bit during its summer, they're not just going to evaporate away. So over time, this red stuff, red gunk on the poles has been building up over these 130-year cycles of getting cold, absorbing a little bit of methane from Pluto, getting hit with some ultraviolet light, mixing with ice, coming back into summer, rinsing and repeating. And if you do that over time, you can build up this whole red structure that we see in these pole regions. The equator is never in shadow for those really long periods of time, and that's why the center of Pluto doesn't have the same kind of red color that the poles do.
Oh no.
Fraser's
muted.
Oh, there we go. Sorry. I've been trying to mute my microphone as we madly discuss the technology back here. It's super interesting to sort of see this get figured out, and it's one of these gigantic surprises. And I'm just wondering, I know you're working on rings, but now, boy, does it make you wonder if you should just switch your thesis now?
A little late for that, but we still have at least another month of data coming back from the New Horizons spacecraft. So all of the information necessary to answer these questions might not even be back at Earth yet. And that's the most exciting part of this mission is we'll continue to learn new things about the Pluto-Sharon system for a number of years to come.
Yeah, it's just like a whole bunch of presents get opened up one after the other into the far future. Well, thanks a lot, Morgan. I know you got to run now, and so we will
not make people change thesis topics. That's just awful.
What? I don't actually have that power, Nicole.
I know.
But it
hurts me.
But you know that if I
Academic
could,
Sandbox.
I would. Right? Like, just, we both know that if we could just follow my whims, squirrel.
We'd never graduate.
No one would ever graduate. Yeah. All right. Well, thanks, Morgan. And hopefully we'll see you next week. All right. Let's move on to.
See you, Morgan.
Let's go on with Yov. Give us the update, Yov.
Hi. First of all, the last month is not a very good month in the Israeli space industry business. You've probably heard about the MO6 explosion during the Falcon 9 accident in Cape Canaveral.
We saw it. We saw the after effect in person. Actually, we were just at Cape Canaveral last week, and we got to as part of our bus tour, we got to drive past the gantry, and it was a disaster. Yeah.
It was a disaster, and nobody expected that. It never happened this way since the 60s, I think. That the launch vehicle exploded on the launch site.
Yeah, that was just a static fire too.
It was before that. It was during fueling.
Yeah,
so we're gonna try and. Can you bring the audio in? We're gonna try to do something a little special here.
Oh, bring the audio in. Okay.
Yeah, let's try and do it.
Sure.
Sorry.
Okay.
And then
do it live.
Do it live.
Okay.
Yeah.
We'll do it live. Here we go. Let's see if this works. We're gonna show a little chunk of the video.
This might work. Okay.
Okay. Yeah. That's where the SpaceX rocket exploded earlier this week, and you can actually see the damage to the gantry. So that was a bonus while we were here. There you go. Did that work? The audio come through? I hope I don't have to file a copyright takedown for myself, but
I don't know if the audience may have heard it.
I hope the audience was able to hear it.
Okay. So this was a disaster in our side. Not only because it never happened before. It was the biggest satellite that we've ever built here. I was actually in the project at the beginning of it, so it's very sad. But most of all, the Israeli industry is much smaller than what you're regular to hear. Let's say in the United States, the budgets are, I think, 1 promille from what you're expecting of what NASA is having, for example. So if we don't have a procurement from another customer, then we don't have anything to build right now. And this is actually what the situation is right now. We have the Israeli aerospace industry, which is the major contractor for satellites in Israel, is building one communication satellite each 3 years, 4 years, something like that. And that's all. And if you don't have a satellite on space, in orbit, then you really have to get another one somehow. And Spacecom, the owner of the satellite, it's also an Israeli company. They also have a big problem here because they also lost the Amos 5 satellite about a year ago. The satellite just lost all of a sudden. It was not an Israeli satellite. It was not manufactured in Israel. It was a Russian satellite. But Spacecom lost 2 satellites actually in such a small period of time, such a short period of time. So they have a problem, a real problem, and they need somehow to finance the next satellite. The industries need to have something to work about the future satellite, or at least a satellite to replace this one. And the users of the satellites, for example, Facebook was one of the users that was supposed to use the Amos 6 services, will probably work with another company instead. So it's quite a mess, and quite a mess in the insurance business also. It's a first.
It's a first in that it was destroyed before it reached the launch pad and before it went up into space. So, I mean, how is that being handled?
Usually, when you own when you procure a satellite, you also have an insurance, but the insurance is valid only when the launch is beginning, only when the engines are starting. But this was not the case. So the launch insurance didn't even begin. So it's up to the Israeli industry to compensate on that. And that's also a problem because the money have to come from somewhere. And because it's a really big issue here in Israel, because this is a very significant infrastructure for communication, then it's also up to the government to say something about that and hopefully to help in this situation. The industry, the space industry is in Israel is very small and very low budgeted, but yet we have 11 or 12 active satellites currently in orbit. So it's quite a lot for this size of a country.
Yeah. Well, keep us posted, and I hope that the replacement does get built and does get launched, because it'd be nice to have that operation. So please keep us posted. Thanks, Yov. Dave Dickinson.
Yes.
Juno passes Jupiter, and we've got some pictures and some data.
Yeah, it's kind of an interesting story that developed this summer while we were on hiatus. On July 1st or July 5th, the Juno spacecraft, NASA's Juno spacecraft, arrived in the capture orbit around Jupiter. And just a few weeks ago, we had the first perijove pass of Jupiter, about 4,200 kilometers from the cloud tops, over one pole, back down and under the other pole. And we got some very unique views of Jupiter that we hadn't really seen since Pioneer 11. And this actually were some very straight on views of the polar regions, crescent Jupiter, half phase Jupiter. And we're seeing some very interesting developments in that with Juno, we can probe down through with infrared in addition to the JunoCam visual images. And we're seeing some pretty interesting contrasts, like say to other gas giants like Cassini looking at Saturn. We're not seeing that polar hexagon, but it's interesting that you can see some of the contrast with the little swirls and the cloud tops there. And some of the images I've seen looking at the raw data, you can actually see these big towering cloud masses where they're casting shadows and things. It looks very dramatic. And that's just from the first pass. Juno's got several more. It's not even in its science orbits yet. It's still doing these. It's got two long, very long looping capture orbits that it's doing. Next month, it's going to fire its main engines for one last time and go down into some smaller science orbits. And then we're going to really be able to get at the heart of Jupiter. Juno itself, what it's doing is we're trying to probe and answer a few key questions as far as, is Jupiter a solid mass all the way through? We know it's a gas giant, of course, but does it have a rocky core in there? Is it some kind of like liquid helium super compressed hydrogen core that's in some kind of strange, semi-metallic state? Juno is going to be able to probe that, and it's going till February 2018, I believe they're going to deorbit it. This is also the first mission we've done up to the outer solar system without a nuclear RTG. The Juno has solar panels on it, so that's kind of unique. And that's one thing Juno cannot it's going to suffer a lot of radiation degradation every time it goes through Jupiter's magnetic field and magnetosphere when it probes. So it's only got so long really before it checks out. But it's kind of going to be an interesting mission to watch.
Yeah, this one, I think people were really expecting to see like a burst of activity from the mission, but the reality is that it's all going to unfold in this sort of slow motion as it gets to its final orbit and continues to send back better pictures. So
some of the Aurora images
tuned.
are pretty cool too.
Yeah, yeah.
It's really good right there. Yeah, that was from one of the near infrared imagers. And you're getting some actual interesting, and there was some interesting audio that came out with that too, where you're actually hearing the radio noise of Jupiter up close as it's passing through. So that's kind of nifty. This is only the second time we've entered orbit. Lots of spacecraft have used Jupiter for gravitational assist, even New Horizons. Both Pioneers were at Jupiter, both Voyagers were at Jupiter. Cassini did a flyby on the way to Saturn, but this is only after Galileo the second time we've entered orbit and really parked there to get a good look at Jupiter. Yeah. Hopefully we get the Icy Moons orbiter here within the next decade for the next mission. The pipeline's kind of drying out now, unfortunately. I was thinking that when OSIRIS-REx launched last week, it's that was the only planetary mission this year that went off for NASA, because Mars Insight, that pushed back to 2018. So we're really kind of getting that pipeline bump back from the sequester years we had there a few years ago, unfortunately.
Yeah. Cool. All right. Nicole, I know you've got another story for us. And then we'll probably make this our final one. Oh,
sorry, I'm distracted by the chat.
I know. It's this, and there's multiple chat, and so it's.
Well, I'm trying to bounce between the Slack and the YouTube, but yeah. I just had a real quick story. This was one that caught my eye this summer. It's another ALMA ALMA story, the Atacama Large Millimeter Submillimeter Array in Chile. It's this fabulous image of a blob, but it's an interesting blob. Because it's looking at the gas in a protoplanetary system. So this is a young star to be or young star that has gas around it, and it's building a disk of dusty, rocky material that will eventually become something like planets. And the unexpected thing is that they detected large stores of gas, particularly carbon monoxide, because it's a simple molecule, it's pretty prevalent in the universe, and it gives off a line that we can see in the millimeter wave. That higher mass stars, if you've ever learned about the spectral types of stars, main sequence stars, there's medium-ish stars like the sun, and then there's larger stars and there's smaller stars. The larger stars, we can call them A or F stars, so they're hotter than the sun, a little bit bigger, actually showed a lot more gas around them than the more medium solar type stars. This is not what was expected, because these hotter stars give off a lot more radiation, they give a lot more ultraviolet radiation, and that's thought to push the gas out faster and further. And what they discovered is that these stars are there's the blobs, holding on to these reservoirs of gas for a much longer time than before. And so they're not quite sure why that is, but it's an interesting and cool discovery of all this carbon monoxide gas, which is a tracer for all other types of gas that might be there. Around these particularly large stars. So they're going to try for more higher resolution images. What I really liked about this, and I can't find it in the article to double check, but they did really quick observations. These were like 10-minute, I think this was the one that they were like 10-minute scans to make these detections. So this is just a cool demonstration of, I think it was this one, the power of the telescope, that they could detect these gas clouds in fairly short observation windows. So there's one of the very interesting blobs with the orbit of Neptune shown for scale. So these are much bigger than the disk of the planet forming.
So I think we need to wrap things up, but before we do, let's just, Dave Dickinson, can you give us a quick thing to go see in the night sky?
Well, it's a full moon. As a matter of fact, there is a penumbral lunar eclipse going on right now. If you're over here in Europe and UK, I'm probably going to pop outside afterwards and see if I can see anything going on. I could not convince myself that mid-eclipse that I could see it right before the Space Hangout. I could see the moon, but the moon is very low on the horizon. The penumbral is very subtle. It's not like a partial or total lunar eclipse. So you just see kind of a shading on the moon. But we have a full harvest moon. That's kind of always cool. Though the fall autumnal equinox is next week. So yeah, there's the visibility from NASA, the visibility range right there. So we're right in that moonrise area over here in UK, in Europe right now. So last eclipse of the year. And of course we have the big eclipse coming up next year in 2017, the total solar eclipse. So next year is going to be an interesting year for eclipses.
Yeah, we're actually all going to be, well, many of us, Pamela from Astronomy Cast and I are going to be going to St. Louis, sort of her area. We're booking a hotel, we're getting a bus, and we're going to make a break for the actual eclipse. So
how can I sign on to that? Because I don't live there anymore.
I know. So you're not like, telepathically connected to Pamela anymore. Just talk to Pamela. She'll give you the deets.
I'm most likely going to be.
I gotta go crash at somebody's place.
I already registered.
I'm most likely going to be camping out west. I think Idaho or Oregon.
Yeah, because, Eastern Oregon sounds pretty safe.
Yeah, I think there's a better shot of clear skies out west. I could be totally wrong on that, but.
Well, we will have another chat in a few months where we give everyone just our final definitive, here's what you do. But you've already written a ton on this, David. I know you got a great article, literally like you've got 1 year, get yourself organized. Yeah.
And to be honest, I'm actually pushing that risk because I'm not fully organized myself.
No, neither am I.
I have a rough idea where I'm going to be.
Yeah.
I don't know where I'm going to be tomorrow.
All right, well, let's wrap things up. Dave Dickinson, where do people find out more?
Yes, the coming year, I'm active Universe Today, Sky and Telescope, Listosaur, my own site, astroguides.com, and that's me for the next year.
Where do people find out more?
On Twitter, Massacrated. It's critical mass in Hebrew, but you can write it in English. Massacrated.
Perfect. And Nicole, where do we find out more?
I am Noisy Astronomer. I'm still tweeting, although I don't do a whole lot of stuff online because I'm going, oh God, class prep all the time. I'm a professor up here in New Hampshire. It's awesome. But you'll see me as Noisy Astronomer.
Well, thanks all of you for rolling with us this week as we learn the new technology again. Hopefully next week is going to be far smoother, and then it'll just be like butter. So once again, I'm Fraser Cain, publisher of Universe Today. If you haven't already, subscribe to this channel, and that way you can get not only this show, the Weekly Space Hangout, but all of our guide to space videos. As I mentioned, I'm going to be starting to do some live gaming with my son and then special guests. So we're going to try and bring in astronauts and scientists and things like that and just hang out with them and kill Kerbals. Hard landings. So that's going to be in the works for the future. So by all means, make sure you subscribe and we will get you on board. All right. Well, thanks everyone for joining. Thanks for all of the viewers. Big thanks to the WSH crew. If you want to know how to get into the chat for next week, go to the WSH crew website and instructions I'm sure will be showing up in shortly. So, all right, we're gonna end the stream now. So, thanks for joining us. We'll see you next week.